Say you have an app that recommends nearby restaurants. The first time you load it up, it knows nothing about your taste, so it recommends the nearest restaurants with a good rating. The one at the top of the list is a Mexican restaurant. You think it sounds good, so you eat there. The next day, you open up your app. All the restaurants you've been to so far are Mexican, so when you load it up, that's all it shows you. You choose a Mexican restaurant, locking yourself into a feedback loop, and even when you choose a different restaurant, you've still mostly been to Mexican restaurants. With this hypothetical app, the stakes are pretty low. The worst that can happen is you have a reduced variety in dinners, but what happens when instead of recommending restaurants, the algorithm is recommending places for police officers to go to maximize the number of arrests? And what happens if police officers are already over-policing predominantly black neighborhoods, and it jumpstarts a vicious cycle? With more and more police departments turning to machine learning for predictive policing, we don't need to wonder anymore.
Computers do what we tell them to. Machine learning changes none of that. What it does change is how we do it. With machine learning, the network is trained by giving it input, getting a result from the neural network, grading the neural network on its result, and the network is modified based on that grade and frequently how it got that result. What makes this strategy so powerful is that the neural networks are excellent at spotting patterns in the data that even people don't notice. This means that it can effectively identify the contents of images, but if there's bias in that data, the AI has no context to combat the bias. It simply includes that as part of the pattern in its data and matches it with its own result.
This bias getting into training data sets is serious. In order to provide those gradable example inputs, the amount of data needed is immense, so getting enough, let alone good data, is hard. Experimenter expectancy effects can apply to anything that involves people collecting data. People don't look for what went wrong for the data when the data doesn't look wrong. People also generally assume that their bias is minimal and that they are doing things correctly. In day-to-day life, this is generally a good thing. It can cause problems, but it's usually better not to be constantly racked with doubt about your every action. As with any science, sometimes these tendencies lead bias to be kept in results. Occasionally, an article might misrepresent a skewed study and deceive some people, but the effect is pretty limited. In the scientific community, people are usually quicker to spot faults in study designs and disprove faulty studies, limiting future impact. A neural network can't think or contextualize, it has to accept everything given to it as a fact.
Bias frequently enters not through what is included, but what is excluded. For example, a lack of pictures of black people in Google's training data led to its AI identifying black people as gorillas. At some stage, those pictures were chosen by people. At no point did those people deciding what data to include ask, how well are we including minorities? Because that's an awkward question to ask, but it's one that needs to be. Incidents like these are something the industry can learn from. Missteps like this are going to happen, but we can learn from them to know things like what types of data we need to be careful with, even before we fail though. For each AI project, we need to assess how badly this can fail and be ready to respond quickly.
So what do we do about it? Well, to begin, many of these companies are in favor of and should be encouraged to self-police. The danger of social scrutiny can hurt companies where it matters most to them, their wallet. Though the manner in which companies solve their issues can many times be unsatisfactory. For example, the manner in which Google solved its gorilla issue was through the removal of gorilla recognition from its software, rather than an influx of new data. Training these programmers to focus on recognizing issues with datasets must be a focal point of collegiate education, not as an elective, but as a requirement for completion of a degree in this field. We need more transparent AI designed to allow for a quicker, more effective response.